Our next guest will tell us about cyber attacks on vehicles and on car systems. And also he will present the concept of virtual car. Please welcome DNS.
Hello everyone. So, as you may already know, I'm DNS. Some of you may know me from my previous speeches at different conferences and from my blog or the Twitter, because some of you may follow me, and thank you for that. So today I'll talk about cyber attacks on vehicle systems. It's a rare topic you may not find here on this region, so I guess somebody has to do it, so it will be me, I guess. Regarding the speaker, well, I'm a reverse engineer and malware researcher, DNS. I'm working as a senior software engineer at the Nsoft company, and of course we are hiring, so I never had a chance to say that. If you are interested, we have a lot of positions open and you may apply at our website. Please, if you are interested in topics about hacking and security, you may follow me at my Twitter, Dn5, and two slashes. So I don't know what's wrong with the resolution, but yeah, something is wrong, I guess. Regarding the topic, I guess it's really for everyone. So if you have a bit of knowledge about the electronics and networks, you may apply the techniques that I talk about today in real-life examples. So basically, the topic is presented for everyone, and I will talk in the easiest language I can, because jumping in the car security is not easy, and if you have any questions, you may as well ask me after the presentation. So what is a car actually? Well, it's something made for transport, obviously, and it's really a complicated stuff. It's a part of our everyday life and experience. So why not use it as some type of security mechanism that will help us in the future and not be vulnerable as we have the problem with the World Wide Web right now. So as we already know, it's expensive, yeah, and the main concern about the car technology is it hackable? So a lot of questions I get is, how do you actually penetrate the car, or how do you exploit the car? Well, to be honest, it's not as easy as it's said on the movies and on the TV shows as hackers hack the car systems. So it's not like that. It has a bit of in and outs, and you may spend a lot of time till you reach the experience to actually do something with your car. So a lot of companies and automobile industry became concerned about the car security, and the common thing between the Mercedes, Hyundai, and Tesla is that they all have a particular sector in the company that deals with car security, and they actually have a type of hackers that try to penetrate the system and find vulnerabilities, just like other big companies have. They have the sectors for security. So regarding the connectivity that car actually allows us in 2016 is various. So we have, for example, the wireless network connection. We have the Bluetooth. the radio waves, and of course the CAN bus protocol that give us the root access as a low-level access to the network, which we can do anything with we want to the car system. So I'll talk about CAN bus mostly because it gives us the actual access to the system. Unfortunately, you'll need to have physical access to the system, to the vehicle itself, because the connectivity port for the CAN is, in most examples, the OBD2. And so I'll talk about little what's CAN bus and what it actually does. So let's imagine a car. In this example, it's a BMW, I think A90, I'm not sure. So we have the CAN bus. Imagine the CAN bus is an example of the network protocol that communicates with the ACUs. And in this example, the ACUs, electronic computer unit, I hope you all understand this, is the type of computer unit that deals with particular operation that car system actually invoke through the CAN interface or CAN network. So all these red spots or rectangles are actually ACUs that deals with particular operation on a car. So for example, we have the ACU that deals with wheels and some ACUs that deals with the door system and so on and so on. With some deals with the headlights. So yeah, actually any operation sent by the consumer of the car actually transfers through the CAN bus and then to the ACU. So to actually explore this type of things, you need to have a particular mode of access to the vehicle itself. And the Linux operating system, I'm not sure how many of you use Linux. Okay, Windows. Okay, and OS 6 or any other Unix-based. Okay, so most of the things that we'll talk about today is actually tied to the Linux, because the Linux itself has a module that deals particularly with the CAN bus protocol, and it gives us opportunity to use some of the solutions and exploits through the CAN bus Linux module that kernel itself offers us. So I don't know if any Windows guys will understand this here, but if you are interested in this topic, I think you may already know a lot about Linux systems and everything else. So what's the deal with the Linux and the CAN bus protocol? Well, as I already said, the Linux offers a socket CAN module, which is integrated in the kernel itself from the, I think, 2.8 kernel version. And the Volkswagen researchers have written the type of protocol that you may use over the socket CAN and connect through it to the car system itself. In my particular example, I'll talk about the OBD2 connectivity that most of you have already in your car. So if you really are interested in hacking the car and exploiting it, you may as well use Linux for that. I'm currently rewriting the Linux module for socket CAN to the OS 6, so any OS 6 users here that are interested and knows about C and kernel writing may as well join to the open source project, the socket CAN X, on my GitHub account, and I'd really appreciate it. So as I already said, the socket CAN is a part of the Linux kernel, and it offers part of the CAN utilities that we may use for additional penetration testing and testing the car security. So if you are on Ubuntu, you may as well use the command to get the CAN utils package that is already available in the Ubuntu repository. It's called CAN utils, that offer us a bit of utilities that we may use and that will help us to join the community of car hackers and security. And I'll also talk about VRCar today, which is actually a car engine written in C on top of socket CAN driver module. It's also available on my GitHub, and you may as well clone it and perhaps do a pull request because it's something fresh. And so yeah, about the CAN utils, it's also written by the same Volkswagen researchers, and it offers a lot of utilities that we may use and that I will show you in this presentation and introduction. So I list a few of them here. We have the CAN dump, which actually just dumps a part of the data that CAN interface sent you. We have the CAN GAN, which is actually a good utility that can help us to generate random frames, which I talk about later, to the ACUs. We have the CAN send, which sends a particular type of frame to the CAN interface, to the ACU. And we have the CAN sniffer, which is totally cool tool that you may as well use, and I'll talk about it later. So yeah, let's see. So, for example, we all know that cars are expensive and that we may not allow ourselves to spend a lot of money to buy a car that will just hack and learn security on it. So Linux is awesome because it offers us the socket CAN virtual device, which is actually a module, and the kernel driver that offers us a virtual CAN device that actually is the same thing that is used in cars. So Linux itself is a car. And yeah, we can of course link it up and give the module the type and set it up as an interface. So sudo modpro vcan, sudo IP linked dev vcan 0 type vcan. I can type that just a second. Let's see. So just a second. Okay, for some reason it doesn't want to switch on to the second desktop, but of course. So sudo modprobe vcan actually invokes our virtual CAN device. As you may already know, some of you Linux users may already know what does it do. We have the sudo IP linked div vcan 0 type vcan, which actually invokes a particular driver to the vcan interface, and it gives a type of link. And we of course invoke the vcan 0 interface, which is in this case the interface we previously set up. And we can of course now use all the CAN utils that Linux offers in itself to communicate through the vcan 0 device. I won't show you this in details because I'll talk about VRCar later on. So if you are interested, you will see what happens in the background and how you may use the virtual CAN device on Linux kernels to play with the security and all of that stuff. So I just jump. Okay, so I think you have, I speak too much, I'll be honest. So let's talk about the data that the CAN interface actually sends. So we have a part of frame. Imagine I'm driving a car right here, and if I turn on the headlights that I forget to turn on when I started driving the route, I send the set of frames to the CAN bus, which then transfers to the ACU that deals with particular operation, in this case the headlights. So in this example, the driver actually sends the signal for the headlights, and it's sent to the CAN bus in part of frame, which is actually just a part of hex numbers and hexed format, and it sent it through the CAN high and CAN low signals through the CAN. Because I don't want to speak about CAN too much, it's a really deep topic, and if you are interested, you may as well learn a lot from the ESO standards about automobile network and industry. So I'll just jump to the frames. So in the frame, let's say you have the frame called turn on the headlights. So when the driver entered operation or pressed the button to turn on the headlights, the operation is sent to the CAN as the frame data, turn on the headlights, turn on the headlights, turn on the headlights, to the ACU. And then the ACU knows that it's actually turn on the headlights frame, and it does that particular operation. In this case, oh no, not demo yet. So let's say how you can use the CAN utils to sniff the frames and know a little bit more about your car. So how cool is Linux? Well, it's really interesting how cool is Linux, because it offers us the CAN utils and all the necessary things that developers in the automobile industry use to write a particular type of frames, or the software dealt with the industry itself and the system of vehicles. So I'm just going to connect to the okay, just a second. Okay. Okay, so I'm currently connected to the SSH on my Linux box, and we are currently in the vircar directory, and let's see the interface of the CAN network, how does it look like. So I'm just going to grab the vircar module, which is actually the car engine that I wrote. And so, as you may already see, it's linked up, and it uses the PF-CAN protocol that is actually used in real vehicle systems and car engines. So, how usable is CAN utils? Actually, well, let's say if we bring some device up, for example, we can, let's say, 1, we can 0, add type we can. So yeah, we just set up our virtual CAN device. So for example, if you actually want to test this on your own car, you may use the connector OBD2, which has, I think, the pin number 6 and pin number 14 to deal with CAN high and CAN low signals. So you just connect the device to the computer and to the car itself, and it's same as you basically link up the connection as the virtual device, but just the real car. So we can, of course, fuck. Yeah, so we just linked up our device to the interface, I mean as an interface, so we can as well grab it, and there it is. So I'll just show you an example of how we can use CAN utils to exploit our own car and vehicle systems. Really, it's easy, as in you are just basically listing the frames that are sent through the CAN interface to your device, in our example to the VCAN 0, VCAN 1, and in your example to the actual car systems. So all the frames that are sent to the car ACU through the CAN bus is actually a frame format which holds the CAN ID and then the hashtag following the CAN data frame. And so basically, if you have the CAN frame that says unlock the car, you may as well unlock the car. So what's the deal with it, and where is the security there? It's actually a little bit a longer topic that you may listen about or read about on my blog. So it's not as easy as it said, because all the data frames format are actually stored in a secure place by the automobile industries and the manufacturers, and most of these car manufacturers like the Mercedes, BMW and such actually sell the data frames which are legged and don't unlock the car but is used for diagnostic. So you may already know that most of the cars here for the race are chipped. It's actually the particular example that I'm explaining here. So it's all is done through the CAN bus protocol and the data frames, which enables the car to go faster than it usually goes. So okay, I see that my connection dropped off. Yes. Okay, so fuck. For some reason my VPN drops. I'm pretty sure most of you don't really understand these things, but I'm here to give you a basic introduction because it's actually not an easy topic that you may jump in as, for example, the web app security or server-side security, because a lot of things are not written by the car manufacturer for obvious reasons, so the guys like me don't try to do something bad to it. But of course, you may as well start to learn more about the CAN bus protocol by learning the ESO standards from the car automobile industry. That will give you a brief introduction to how does the car actually operates. I mean, the newer cars, because the old cars actually don't have any particular port that sends the CAN signals. Okay, for some reason, I don't know, my connection drops off. I don't know why. I leave it as a reconnecting. Fuck. I'm really sorry, I don't know why this happens. Okay, so I'll try to reconnect to my VPN again. I can't really explain you the basic of introduction and introduction to CAN interface without Linux. Okay, it says connected. So if we try again. Look. Okay. So yeah, we have our virtual CAN device already up, which is weekend 1. So if we use, for example, weekend damp from the CAN utils, we may as well see the things that help us to deal through the sniffing process. So let's say we use the CAN damp with the weekend 0, weekend 1. Okay, it's listing up. So imagine that we are currently damping the actual interface from the car through the OBD2 port. We will actually write CAN dump and then the device that is configured in our Linux system and that is shown at LSPCI. So the CAN dump is actually a utility that helps us to dump the data that is sent to the CAN and then to the ACU. So for example, we can use also another tool from the CAN utils called CANGen, which actually generates a random data that will be sent through the CAN interface and then onto the ACU. So for example, if we use this, it actually sends a set of frames in the hex format currently displayed. In real life example, the vcan 0, the first row would be actually, the first column would be actually the interface. This is the frame data, following by bytes, and the data itself in the hex format. So any of these operations may or may not be actually a type of valid frame format or valid frame data that is actually known by the car or the ASU itself. So in this example, we are just sending the random type of frames. We may as well use the can-GAN to our interface and send a random type of frames to a real car, but I wouldn't advise you. The real car is built for a reason, because breaking the car engine and the system of the automobile is quite easy, because the CAN is really primitive technology and it can understand too much. So yeah, we have a lot of tools that are actually quite handy when exploiting the car and CAN interface. We may as well use the CAN sniffer, if I'm correct, to the vcan 0 device. Yeah. This type of utility helps us to sniff a set of frames that we predefine with the data we are actually interested in. So in this example, we are dumping the same data we get from the can-GAN, but we may use this sniffer tool to sniff the particular frame that is actually some type of valid operation. So I'll just stop this right here, and I'll explain a little bit how this can affect the car security and what does it actually have to do with us, because when you look at this, you only see the set of frames without any actual valid data, and that's the reason that cars are currently at the security that they are currently on, because if we had access to the data frames sent to the ASU, other type of people like black hats will use it as the actual frame that deals with particular operation, for example, to steal a vehicle or something like that. So I'm pretty sure a lot of guys here are interested in the cars, because we are all males after all. So yeah, to not test your own car, and like me that did something like that, and to not break your own engine, you may use the real car. The virtual car is actually a car engine, which is written in pure C and uses the socket CAN interface to create a type of virtual CAN device, and it actually have the valid formats, just like the real car. It actually has the frames that are valid, but you actually know what frames are valid and which data you may send to do a particular operation, which you can't really do at the car itself. You may, but I'll talk about that later. So how is the real car built? Well, it's simply set up the virtual CAN device, listen to the same device, to the same interface, check for frames. If frames are received, parse the frames and check their data, and at the end, if the frame is valid, return the operation that is sent to the CAN bus. of course, you may as well send invalid frames, just as you can send invalid frames to the actual car system and such. So, as I already said, VRCar is open source, so if any of you are interested in using this as your laboratory, you may write an issue and I'll be grateful if I can help you with something. You may as well write some additional functionalities like the revs, the speed and such. Currently, VRCar is very limited and it offers just a few operations that are actually veiled. Is the engine on, engine off, and the I think door unlock and door lock. These are the veiled frames, and we may use these frames as a type to communicate with our device. So if I'm not sure if okay, so I need to use pseudo here because it's used as the mod probes requires the pseudo or the appropriate settings to run the operation. So in this example, I run the VRCar as pseudo and the device is linked up. We can use if config to check if our device is up, and as you may already see, it's up, and we can use the all the CAN utils that are used to test real car. We can use all of them to the VRCar and experiment. In our example, let's say that we want to send, I don't know, a random set of frames. We can use CAN again to the VRCar device, and our virtual engine will actually understand the frames and parse them out. So of course, none of these frames that are sent to the ASU through the CAN device on our virtual car are actually valid. So we may use the just a second. Okay, so these are some set of valid frames that are actually usable in our car engine. I also write a fuser for the same engine. It's written Ruby and it uses CAN send to send a set of frames data that it may think it's valid. I'll talk more about it later. So for example, we can use some of these frames that are valid to test if operations succeed. So for example, let's say okay, I'll stop this here. So let's say that we use the CAN send to the VRCar interface, and that the frame data includes so this is CAN ID. So in this example it's 1, 2, 3. So CAN ID can be dealt with particular operation. For example, the headlights doesn't have to be the separate. For example, left headlight and the right headlight should be with the same CAN ID. So if you use the CAN send 1, 2, 3, for example, for the headlights or anything else, let's say the valid operation to start a car engine is 4, 5, 4E, 4F, 4A, I think. Nothing happens. Let's see if this thing registers it. Okay, it doesn't. Ah, yeah, it does. It's up to resolution. So in this example, I showed how this frame actually sends a valid operation to the ACU. In this example, it's N on. The engine is on, and rear car actually informs us that rear car engine is turned on and that it's usable. For example, the same frame can be used on the car system if it's valid and if you are connected to it instead of the virtual device. Yeah. So you may use the virtual CAN to test your knowledge about the car security if you are really interested in it. I think it's the first car engine written in C that actually registered the correct flags. All of other samples are actually just the overwrite of the CAN send and other CAN utils to the system. So in case you are interested, you may use it. And of course, try to use it in the type of the open source, because it actually is open source. So any pull request to your push is highly appreciated, because just a few of the guys actually work with this type of things. So I presented you the virtual car and how it can help you to learn more about the car and automobile industry in the IoT world. And so yeah, this is how it's made. It's the paragraph. So actually it opens the CAN interface over the PF CAN, which only the Linux currently supports it without external models. The Windows support it, but you have to install some additional DLLs. And OS X is totally out of this region, and you may either use virtual machine or hop in and rewrite the Linux kernel module with me and Car Loop, which is actually cyber security firm that deals with the car security only. So I'm the part of it, and we are rewriting this same socket CAN module to the OS X. I don't know if any of you write OS X drivers, but yeah. So I also wrote a rear car fuser. It's a Ruby script, and it actually fuses your virtual car with the random strings actually from the word list. That it also allows the generation, and it's highly customizable, and it attacks the CAN protocol and CAN networks. So I don't know, Ruby is quite easy, so you may join in and rewrite some of the tools or try to think about additional things that can help other car hackers to use it and practice on. It's actually a tool, a simple tool. It's based on CAN utils, actually CAN send, and it actually sends the frame converted from the word list to the hex onto the CAN interface to the ACU, in this case the rear car engine. So I'm not sure if you are interested in showing you the demo for the rear car fuser. I don't think it's that much. You may check it as well on my GitHub and learn a lot of things from it. Yeah, this is how it's made. So it's actually a fuser. It fuses a CAN frame to the word list onto the CAN bus interface and then to the rear car, which then rear car checks if the frame is valid and then returns to the fuser if the operation succeeds or not. It's really primitive and simple, but it's extensible, and yeah, that's about it. I don't want to take too much time about regarding the worker fuser, and I'll talk about something else. In this example, the real-life attacks. As far as I know, most of the speech that deals with car hacking and car security actually don't provide any real-life attack and examples. And if some of the people question about it, that listen that particular talk, they either ignore it or I don't know, they don't want to answer it, because most of the guys that deals with the car security are actually in the car industry itself, so they don't want to reveal their own secret. So I'm here to answer you all the questions you have regarding this, because I'm not in car industry, thankfully. We have a part that we may use to attack the car vehicle itself, but it's not as it's said or seen in movies. So for the first thing, why it's not advisable? Because, well, cars are expensive. You can break the car system, the car engine, and other stuff like the ECUs or just various things that you don't want to deal with or don't want to pay for additionally. You may use for example, if you want to teach yourself more about something in particular car, for example, if you want to learn more about the dash or the headlights or the door of the car, you may just use the ECU that is dealt with that particular door. So yeah, if you really want to try something about this in real life example, my answer is don't do it. But if your argument is I don't care, I want to break my car, or I want to try this on, so these are the few type of so-called vulnerabilities that you may use. Actually, none of these are vulnerability. It's, for example, the DBC. So DBC, what is DBC? It's actually a format that holds all the frame data for particular car model, and all these frames are valid. For example, you have, I don't know, Mercedes.dbc that holds all the frames for that particular model of Mercedes, and you actually can send the DBC frame data, actually the frame data from the DBC file to the CAN bus, and then that operation will magically appear. That's actually how most of the diagnostic tool works. So they have a part of the database that checks only for error checks that you may not use additionally to unlock the car to, I don't know, for example, fuse the engine or something like that. They have just to see if the frame is valid and is it okay, then car diagnostic returns the one. Actually, it doesn't return anything, but the frame passed and it's valid, so that type of thing is okay. In case if some frame is sent but is not seen to the ASU, then there's something wrong with your car, and that's actually the car diagnostic. It's not some kind of magic. It's actually pretty easy. So the DBC file are actually only kept on the manufacturers in South, and to some type of OBD softwares and something like that pays a huge amount of money so they can use the same software to diagnose your vehicle. So DBC is actually a great hacking technique, but it's not available to us people that doesn't deal with car security too much or something like that. We have the trial and error, which is obviously the type of hunting that we use every day. Most of developers use this as a type to fix some bug or something. So trial and error is an essential. If you have a ASU connected to the canvas and to the operation, so for example, if you disconnect that ASU or that device, of course, that frame won't be valid. So there you have it. That's the frame that is valid and that you may use to penetrate the car or something. This is actually quite a technique, but it takes too long to learn more about it. And you have really to be precise to the car model that you will test and such. And it takes a lot of time, and I think most of you don't have additional hobby time. So we also have a fuzzing technique, which is actually used by the rear car fuzzer. You just try to pin the car system by various frames that you may see or sniff and that you may think they are valid. So I think Chris Miller showed an example of this. If you have a frame that you sniffed before and see a repetition of that frame through the CAN bus protocol, that means that that CAN frame is actually, for some reason, it's usable, and you may as well try to CAN send it through the CAN interface and check what does happen with your car if you send it. So fusing is, of course, a long-taking technique, and it's the only technique that may actually break your car. For example, DBC won't ever break your car since the frames are valid, and the trial and error are actually a fundamental thing that you may check. You may break your car, but not that much, so to say. So yeah, I'm currently also writing a type of CAN-util additionality that will have, as you may already seen, the CAN-utils have the CAN sniffer. It's a great tool, but it doesn't give us too much information about the traffic that we sniffed. So I'm currently building a tool that will actually sniff the traffic. Then actually when you disconnect the device, it will show you a kind of diff, what changed between the operation that you dealt with before you disconnected your device and after you disconnected your device. This will help with trial and error technique to actually penetrate your car and explore additional vulnerabilities. So yeah, that's the, this is the explanation of the engine. It's currently private on my GitLab, but I hope I'll release it soon once I finish with the car loop and module for OS 6. So fusing, I think most of you will now come home and think about, well, let's try the can-gen command on my car. Well, I can only say you don't do that because I'm not responsible for anything you do. It will actually break your car. That's how the automobile industry protect themselves from this type of attacks. So yeah, this is a little bit more about the DBC. It actually holds valid frames, but unfortunately it's not available to us. Of course, I may also say that some of the DBC files for older models are leaked and either sold to the black market or they are available if you try to search through the Pirate Bay or some other websites too much or too deep. Yeah, they are available but hardly to find for newer models and newer type. Yeah, of course, I'd like to thank my sponsors. So yeah, Nsoft, it's the company I currently work as a software engineer. We have the opening position. It's a huge company, and you are welcome to join us. we are located in Bosnia and Herzegovina. The Spark that currently sponsors also my talk, the car loop, is the company located in Silicon Valley that I do work with in, so to say, rewrite all the stuff that are available to Linux and to Windows to the OS 6, the known server, of course, my sponsors that offer me VPS and DADI servers for all the hacking that I do, and a local startup called grad.ba, which you may check additionally. I don't want to speak about too much, it's a cult. Yeah, so that's it. I don't know if you have any questions, but I'm here to answer you. I know this is a kind of hard topic to jump in, but you have heard much to learn about it.
Thank you. Have you thought about getting some ECUs from like Bosch or eBay and emulating their firmware, like emulating them and putting them as a module into your virtual car so you can actually fuzz real firmware without damaging too many cars?
Well, yeah, I thought about it, but it's the actual problem with the how to say, the frames are actually not the frames that mean something. For example, in virtual car, the frame for engine on is N on in the hex format, but in the actual car, the frame for example engine on is some render character or something like that. So you can't really know what the frame actually does if you don't inspect it too much. For example, for one frame to give it too much time to explore it and to learn how you can use that frame in your own engine. But I hope so to implement a way of the public DBC files to the virtual car, and for example, if you want the engine for the Ford or so, it will only be available for the specific frames for that Ford model or something like that. So in the future, yes, of course, but you may as well join to the project and commit.
Yeah, I was thinking, is it always the same frame? So command, for instance, to turn the engine on. Is it always just one frame? Or maybe there are like cars where there's a combination of frames that turns the engine on. Like you have to send 3 frames in sequential, the bullet
Yes.
thing.
Well, the problem with the CAN frames is, yes, they are always the same because the technology of the CAN interface and CAN network is primitive and it can't understand if the frame is actually just an alias for that particular operation. But the thing is that the frame itself actually does send through the CAN bus, through the ASU in repetitive order. So it's not like turn the engine on and that's that. No, it's if your engine is turned on, then you may inspect your frame that deals with the engine on, because you'll see the pattern of it repeating, you know, in the sniffer or the dumping the data. So the engine on will just send engine on, engine on, engine on, engine on, engine on, and then you may as well inspect a bit that that particular frame is actually an engine on frame that you may use additionally. Any other questions? Thank you.